When a new material proposal lands on a designer's desk, the first question is usually about what it brings to the table. The natural instinct is to look for addition. We tend to measure the success of a material by how much stiffer, lighter, or tougher the new option is compared to the baseline. But this often leads to the substitution trap. You swap out a line item in the spec sheet for something premium, like titanium or a carbon composite, yet the actual physical drawing stays entirely unchanged. If the geometry of the part does not evolve, that is a substitution rather than a design decision. It is an expensive upgrade that has not earned the cost of the qualification program you are about to run it through. A rigorous material choice operates in reverse. You don't choose a composite for what it adds to the object, you choose it for what it allows you to take away. To see this deletion test in practice, look at how the top tier of automotive design handles bespoke rebuilds. Take the Eccentrica V12 Roadster. It starts life as a first-series Lamborghini Diablo, engineered to carry a massive 5.7-liter naturally aspirated V12. Removing a roof from a chassis engineered to have one is a serious structural liability, not a styling exercise. To make this open-top car work, the team reconstructed the entire body in carbon fiber. That extreme material cost is exactly what pays for the missing roof. You see the exact same logic in the Gunther Works GXR Evo, which reshapes the 993 generation Porsche Coupe. The carbon fiber serves a single structural purpose here. It allows the heavy rear glass, its rubber seal, and the metal surround to stop existing. The design team did not restyle the back of the car. They removed the part entirely, closed it over, and replaced it with a rigid, integrated shark fin that creates an entirely new silhouette. In both builds, carbon fiber acts as the mandatory payment required to rip a core component out of the vehicle and still have it hold together at 200 miles per hour. The Aston Martin Velan takes this idea straight to the surface. Limited to 150 units, the car is offered with a fully exposed exterior. Deleting the layer of paint forces the underlying carbon structure to advertise itself, altering what the object is willing to admit about its own construction. This exact rule applies at a massive industrial scale. At Milan this year, Mush Composites debuted Biolithic, monolithic architectural forms designed to read like solid stone. But they aren't stone. These structures are grown from mycelium inside a computationally derived formwork. The company states the position plainly. The material is grown, not quarried. This biological process entirely eliminates the heavy extraction step from the supply chain. That erasure leaves you with an architectural surface that carries the physical presence of concrete, but at a 70% reduction in mass. The difference between a substitution and a design decision comes down to that test. When you remove a roof, a coat of paint, or 2/3 of an architectural mass, the deletion becomes the most visible part of the product. But pulling off that kind of absence requires absolute precision. You have to perfectly plan the void from the very first sketch. Working with generative AI introduces massive friction. By default, these models drift, hallucinate, and their outputs subtly mutate away from your intent. Novelty works for demos, but professional design requires absolute structural consistency. Any drift in geometry becomes an expensive liability. This is the problem Depix solves. Our design intelligence tools force generative models to hold true to your exact constraints, ensuring that the void you designed is protected at every stage of the workflow. Because physical tooling is unforgiving, the intent to delete a component must be perfectly visualized long before you ever cut the first mold.